In the past, we've talked about a concept called simple interest. Now what we want to talk about is compound interest. So let's look at an example of compound interest. So suppose you deposit $1,000 in an account that earns 10% interest, compounded annually. So compounded, what this means is you actually earn interest off of the interest that you earned previously. So that's the compounded part, is that you're earning interest off of interest. And this is one of the best ways to actually gain some wealth. What we want to do is determine how much we would have in an account at the end of each year. And we're going to do this for probably about 4 years so that you can start to see the pattern. So let's just look at it here for the first year. So here in year one, if you deposit $1,000, that's going to be your principal. And then interest that we had just from last time, from simple interest, remember it is the principal times the rate times the time. So at 10% interest for 1 year, we would have the $1,000 that we deposited, and we see that we would earn $100 off of that principal at the end of the year. So at the end of the year, in that account, we would have $1,100. The 1,000 that we deposited, the 100 that we earned off of interest. So now when we go into the second year, we start that second year with $1,100 in the account. We compute the interest that's earned off of the $1,100. So we would have $1,100 times 10% for 1 year. Well, we had the $1,100 in there. We earned this time $110 in interest. So when we add the principal that we had plus the interest at the end of that second year, we see that we have $1,210 at the end of the second year. Let's look at the third year. So we start the third year with the $1,210 that we had at the end of the second year. We take that $1,210 and multiply it by our interest rate, our annual rate of 10% for 1 year. So now we have the initial amount, or the amount we had at the beginning of the third year, which is the $1,210. The $121 is the amount that we would have earned in interest at the end of that third year. So when we sum these two, we get $1,331 in that account at the end of the third year. So before we go to the fourth year, let's just examine these here. So what you see is your interest each time is increasing a little bit at the end of each year because you earned interest off of the interest earned in the previous year. So let's see how this would map out then for the fourth year. So for the fourth year, we have the $1,331. So we would have $1,331 in our account. And we're going to earn some interest off of that. So we would take the $1,331 times the 10% for 1 year. And that is going to give us the $1,331. That was what we had at the beginning of this year. When we compute this piece right here, the $1,331 times 10%, that gives us $133.10. So now when we sum these two, we see at the end of the fourth year, we have $1,464.10 in the account. So you see the compound interest then actually allows us to earn a little bit more money throughout those 4 years. So what would happen now if we compute this using simple interest? So let's look at it here. If the same amount of money was deposited in an account earning simple interest, the amount at the end of 4 years would be, so remember when we did simple interest formula, that one is F is equal to P times 1 plus RT. So the future value when I put in $1,000 would be 1 plus the 0.1, my 10% interest rate, and I'm going to do that for 4 years. So when I compute this then, we get $1,400. So what you see, here's the simple interest, here's the compound interest. So using compound interest, we would actually earn $64.10 more because it was compounded, because we used compound interest instead of simple interest. Okay, so now let's look at compound interest in more of a general term. So suppose we have principal P, and it earns interest at an annual rate of R, where R again is expressed as a decimal in our formula here. The interest is going to be compounded M times a year, and I'll talk a little bit more about what compounding periods really are in just a second. Then the amount F, or our future value, after T years, we'll have F is going to be equal to P, which is the amount you deposit, or the principal, the initial deposit, is 1 plus R, which is your interest rate, as a decimal, divided by M. And M is going to be the number of times that it's compounded per year. And this is raised to M, which again is the compounding periods, times T, where T is the amount of years that you have the money in that particular account. All right, so we'll do, I just want to make some notes here that F is future value. I'll fix that here in just a sec. Future value. P is the initial deposit. R is the interest rate. And again, this is an annual interest rate. M is the number of compounding periods. Okay, so let's talk about this just for a second. So the number of compounding periods, you could have something that's compounded annually. If it's compounded annually, that means it's just one time per year. So M in that case would have a value of 1. If it's compounded semi-annually, that means it's compounded twice a year. So M would have a value of 2. There's a number of different values. It could be compounded monthly, in which case M would have a value of 12 because there's 12 months in a year. It could be compounded weekly. There's 52 weeks in a year, so M would be 52. And then it could also be compounded daily, which would be 365. That's what we would use as a value for M there. All right, and then the last one we have here is T, and T is time. Remember, the units here is in years. All right, so let's look at this then in terms of an example.